Hey gentlemen, welcome back to Dental Miracle. If you have been following the tooth regeneration story, you have probably seen dozens of headlines claiming we are on the verge of regrowing teeth. But here in early 2026, what is the actual reality? Are we months away from ditching dental implants, or are we still years from this becoming mainstream? Today, we are cutting through the hype and giving you an honest reality check on where tooth regeneration actually stands in 2026. If this is your first time here on this channel, we break down the latest breakthroughs in dental medicine so you can understand what is real and what is just marketing. Make sure to subscribe and hit that notification bell so you do not miss any updates on this revolutionary technology. Let's start with the big one, Japan's TRG-035, the usag-1 inhibitor developed by Dr. Katsu Takahashi and Toregem Biopharma. This is the most advanced tooth regeneration therapy in the world right now. And here is exactly where it stands as of February 2026. The Phase 1 clinical trials were completed back in late 2024. These trials focused primarily on safety, testing the drug on a small group of patients with anodontia, that is a genetic condition where people are born missing several teeth. The good news, the safety profile looked promising. No major adverse events were reported, and the drug was generally well. Now, Phase 2 trials began in mid-2025. These trials are larger, involving more patients, and they are designed to test both safety and efficacy. Here is the reality check. As of February 2026, these Phase 2 trials are still ongoing. We are expecting preliminary results sometime in late 2026 or early 2027. What does this mean for you? It means we are still in the data collection phase. Researchers are carefully monitoring participants, measuring tooth bud activation, tracking growth rates, and documenting any side effects. This is meticulous, time-consuming work, and it has to be. The earliest optimistic scenario for Phase 3 trials would be late 2027. And even if everything goes perfectly, we are looking at regulatory approval processes that could take another 2 to 3 years. So realistically, for the average person with missing teeth, TRG-035 would not be available until 2030 at the earliest, possibly 2032 or later. I know that is not what you want to hear, but that is the honest timeline based on how drug development actually works. Okay, so if we are still years away from availability, what have we actually learned from the research so far? Quite a bit, actually. First, the animal studies have been incredibly revealing. In ferret models, which are considered excellent proxies for human tooth development, TRG-035 successfully triggered the growth of third-generation teeth. These were not just tooth buds or partial formations. These were functional teeth with enamel, dentin, and proper root structures. The success rate in ferrets was around 75 to 80%, which is remarkable. Mouse models showed even higher success rates, but mice naturally have different dental biology than humans, so we take those results with a grain of salt. The ferret data is what really matters. Second, we have learned about the mechanism. TRG-035 works by blocking usag-1, a protein that suppresses the development of extra tooth buds. All humans actually have dormant tooth bud genes, genetic remnants from our evolutionary past when we could grow multiple sets of teeth throughout our lives. By blocking usag-1, TRG-035 essentially unlocks these dormant buds and allows them to develop into new teeth. The drug is administered as an injection directly into the jawbone near the site where the missing tooth was. It is not a pill you can take at home. This is a clinical procedure that requires precise imaging and skilled administration. Third, and this is crucial, we have learned that this therapy works best for people with congenital tooth loss, meaning people who were born missing teeth or lost them due to genetic conditions. The question of whether it can regenerate teeth lost to decay, trauma, or age-related gum disease is still being studied. The biological environment matters a lot. If you have lost significant bone structure due to advanced gum disease, tooth regeneration becomes much more complicated. Now, Japan is not the only player in this game. Let's talk about what else is happening around the world in 2026. South Korea has been making noise about a tooth-regenerating microneedle patch. This is a different approach. Instead of an injection, it is a dissolvable patch that you place against your gums. The patch contains growth factors and signaling molecules designed to stimulate tooth regeneration. As of 2026, this technology is still in early-stage trials, probably about 3 to 5 years behind Japan's TRG-035. We are watching this closely, but do not expect results anytime soon. In the United States, researchers at Penn Dental Medicine have been exploring laser-activated stem cell therapy. The idea is to use low-level laser therapy to activate the stem cells in dental pulp, potentially triggering tooth repair or regeneration. This research is still mostly in the laboratory phase. We have not seen human trials yet. Harvard Medical School has been working on gene therapy approaches, manipulating the BMP and WNT signaling pathways that control tooth development. Again, this is fascinating research, but it is in the early experimental stages. China has several stem cell research programs focused on dental regeneration, but information coming out of these programs is limited. Some reports suggest they are making progress with stem cell-derived tooth structures grown in laboratories. But translating that to in vivo human tooth regeneration is a massive leap. The reality is that Japan's TRG-035 is the furthest along by a significant margin. If you are hoping for tooth regeneration in your lifetime, you are basically betting on Japan or waiting for someone else to catch up, which could add another 5 to 10 years to the timeline. Let's talk about the challenges that still need to be solved. Because even if TRG-035 gets approved, there are practical questions that researchers are still working through. Challenge number 1, controlling tooth position and orientation. When you grow a new tooth, it needs to emerge in exactly the right position, at the right angle, with proper alignment to your existing teeth. The last thing you want is a tooth growing sideways or at an awkward angle. Current research suggests that the injection site and dosage control are critical, but we are still learning how to optimize this for different jaw structures and positions. Challenge number 2, growth timeline. In animal models, tooth development takes anywhere from 2 to 9 months, depending on the species and the tooth type. We do not yet have definitive data on how long it will take a human tooth to fully develop after TRG-035 injection. You would not walk out of the dentist's office with a new tooth. This is a months-long process, and during that time, you might need temporary prosthetics or adjustments. Challenge number 3, patient eligibility. Not everyone will be a candidate for tooth regeneration therapy, at least not in the early years. People with severe bone loss, certain autoimmune conditions, or those taking specific medications might be excluded. Age could also be a factor. We do not yet know if there is an upper age limit beyond which tooth regeneration becomes unreliable. Challenge number 4, cost and accessibility. Even after approval, TRG-035 will likely be expensive initially. Think tens of thousands of dollars per tooth, at least in the first few years. The procedure requires sophisticated imaging, skilled clinicians, and follow-up care. Insurance coverage is uncertain. Over time, costs will come down as the technology matures, but early adopters will pay a premium. Challenge number 5, long-term durability. Will a regenerated tooth last as long as a natural tooth? We simply do not have 20 or 30-year data yet. The animal studies are promising, but humans live a lot longer than ferrets. We need to understand the long-term success rates before this can truly replace dental implants. All right, let's get practical. If everything goes according to the most optimistic timelines, what might tooth regeneration look like by 2030? By 2030, assuming TRG-035 gets regulatory approval in Japan, we could see the first commercial availability of tooth regeneration therapy in Japanese dental clinics. The initial rollout would likely be limited to major cities: Tokyo, Osaka, Kyoto, and 2 specialized clinics with the proper equipment and training. The patient pool would initially be restricted. Priority would go to younger patients with congenital tooth loss, the group that has been studied most extensively. Over time, eligibility would expand to include people who have lost teeth due to trauma or other causes. The procedure itself would probably look something like this. First, comprehensive 3D imaging of your jaw to map the optimal injection site. Second, a single injection of TRG-035 into the jawbone performed under local anesthesia. Third, regular monitoring visits over the next 6 to 9 months to track tooth development. Fourth, potential orthodontic adjustments once the tooth has fully emerged. Cost estimates vary wildly, but based on similar regenerative therapies. We are probably looking at $5,000 to $15,000 per tooth initially in Japan. Medical tourism could make this more accessible, with patients traveling to Japan specifically for the procedure. Outside of Japan, approval timelines get murkier. The FDA in the United States, the EMA in Europe, and other regulatory bodies would each conduct their own reviews. This could add 2 to 5 years beyond Japan's approval. So, for Americans or Europeans, we might be looking at 2032 to 2035 before this is available domestically. By the mid-2030s, if the technology proves successful, we could see costs drop significantly. Insurance coverage expands, and tooth regeneration become a standard option alongside implants and bridges. So, here is the reality check you came for. Where do we actually stand in 2026? The science is real. Tooth regeneration is not science fiction. The animal data is compelling, the mechanism is understood, and human trials are underway. This is happening. But, and this is a big but, we are not around the corner from this being available to the average person. If you are watching this video because you lost a tooth last year and you were hoping to regrow it instead of getting an implant, you are going to be waiting at least 4 to 6 more years, possibly longer. If you need a tooth replacement solution today, dental implants remain the gold standard. They are proven, they are reliable, and they can last decades with proper care. Do not put off necessary dental work hoping tooth regeneration will arrive next year. At the same time, if you are young, if you have time on your side, and if you can afford to wait, the future looks genuinely promising. By the early 2030s, tooth regeneration could be a real option. The key is managing expectations. Social media and YouTube headlines, yes, including some of ours, can make this technology sound more imminent than it really is. Drug development takes time. Safety testing is non-negotiable. Regulatory approval is rigorous. These are good things. We want this technology to be safe and effective when it finally reaches the market. So that is the honest 2026 reality check on tooth regeneration. It is exciting, it is real, but it is not quite here yet. What do you think? Are you willing to wait for tooth regeneration, or are you moving forward with implants? Let me know in the comments below, and if you found this reality check helpful, please give this video a thumbs up and share it with anyone who has been asking about tooth regeneration. For more updates on TRG-035, dental breakthroughs, and everything happening in regenerative dentistry, make sure you are subscribed to Dental Miracle. We will keep you updated with honest, science-based information as this technology develops. Thanks for watching, guys, and I'll see you in the next video.